Imagine freezing a video of a moving tiger and seamlessly rotating the camera around it in mid-air, just like a Hollywood bullet time effect. This level of control has traditionally required heavy 3D reconstruction, but new research asks, can we achieve this using only generative video models? The challenge with current technology is that space and time are often entangled. If you try to move the camera in a generated video, the speed of the action usually distorts or changes, effectively breaking the illusion. Traditional fixes like 4D reconstruction are often too computationally heavy for widespread use. To solve this, the researchers introduced SpaceTimePilot, a method that uses generative diffusion to disentangle these two forces. It allows a user to control the camera trajectory and the playback timing completely independently, enabling effects like bullet time without needing complex geometry. Let's dive into the architecture and training strategies that make this disentanglement possible. The core of the system relies on feeding two distinct control signals into the diffusion model. On one side, it processes spatial coordinates to understand the camera path, and on the other, it uses sinusoidal time embeddings to control exactly when an action occurs within the frame. A crucial innovation here is what the authors call source-aware conditioning. Unlike previous models that only look at the destination, this model explicitly accounts for where the original camera was positioned, which drastically reduces errors in specific trajectory tracking. Since there is no perfect 4D dataset in the real world, the researchers had to be creative with training. They used a technique called temporal warping, where they artificially reversed, froze, or slowed down existing multi-view videos to teach the model how to respond to time control signals. Now that we understand the mechanism, let's look at how it performs against state-of-the-art baselines. This figure demonstrates a difficult stress test, reversing the video playback while simultaneously panning the camera physically to the right. While comparable baselines struggle to separate these movements, SpaceTimePilot maintains correct geometry, even while the time creates a reverse motion effect. Finally, Qum's AI now have The capabilities extend beyond short clips, as seen in this figure of a tiger. By using an autoregressive approach, generated segments serve as memory for subsequent frames. The model creates long, consistent explorations, allowing for a complete rotation around the subject. Of course, the method isn't perfect. It relies on a heavy 1.3 billion parameter backbone, and can still struggle with extreme visual occlusions. However, the significance is clear. It successfully unlocks interactive scene exploration and bullet time effects from a single video source. To learn more, head to emergentmind.com.